Hello students, it's 11th chemistry. Our topic is redox reactions. Redox reactions, we know that these are very important in our day-to-day life. We know that we take food, we respire, by respiration we take oxygen, and this food is oxidized. Similarly, to release energy, we have this burning of gas, burning of wood. These all are oxidation processes. Similarly, we have many industrial processes, like we have electroplating, production of caustic soda, potassium permanganate, extraction of metals like sodium, iron, aluminum. These are all examples of redox reaction. So these are very important in our daily life. So we need to understand this. First, let us see what is oxidation. Oxidation has two these definitions. One is addition of oxygen or any other electronegative element. When we add oxygen or any electronegative element to some other element, the reaction is oxidation reaction. For example, we have carbon. When we burn carbon, it combines with oxygen to form carbon dioxide. So here oxygen is added to carbon, so this is an oxidation reaction. Similarly, magnesium, when we burn magnesium in iron, it turns into magnesium oxide, MgO. So here oxygen is added to magnesium, so it is an oxidation reaction. Similarly, if we make a reaction between zinc and sulfur, we get zinc sulfide. So here sulfur is added to zinc. Sulfur is electronegative element. Similarly, when we make a reaction between magnesium and chlorine, chlorine is added to magnesium. So electronegative element is added to magnesium here, and here electronegative is added to sulfur. So these also are oxidation reaction. So addition of oxygen or electronegative element. There is another definition, removal of hydrogen. If we remove hydrogen or any electropositive element, removal of hydrogen or any other electropositive element, this reaction is also oxidation reaction. For example, here we have H2S, hydrogen sulfide. Then we add oxygen to it, we get water and sulfur. Here hydrogen is removed from hydrogen sulfide. So this is an oxidation reaction, removal of hydrogen. Similarly, we have potassium iodide. When we make a reaction between potassium iodide and chlorine, we get potassium chloride and iodine. Here iodine, this is an potassium, which is an electropositive element, is removed from iodine. So this is also an oxidation reaction, and iodine gets oxidized because electropositive element potassium is removed from this iodine. Then we have another related term here, that is oxidizing agent or oxidant, a substance which is used to add oxygen. A substance which gives oxygen or an electronegative element to another element, that substance which gives oxygen is called an oxidizing agent. Similarly, any substance which removes hydrogen or electropositive element is called an oxidizing agent. In this case here, oxygen is itself added to it, so oxygen is oxidizing agent. In this reaction of magnesium oxide, oxygen is added directly to magnesium, so oxygen is the oxidizing agent. Here sulfur is added to this, sulfur is the oxidizing agent. Here chlorine is the oxidizing agent because these are added to these. Similarly, here oxygen removes hydrogen from sulfur. So here oxygen is again the oxidizing agent because it removes hydrogen from sulfur. Similarly, chlorine removes potassium from iodine. So here chlorine is the oxidizing agent. Then we have reduction. Reduction is this is exactly reverse of this oxidation. Here we have removal of hydrogen or any other electropositive. Here in reduction, it is the addition of hydrogen or any other electropositive element. When we add hydrogen, when we add any other electropositive element to an element, so the reaction is reduction, or we say the substance reduced. For example, we have chlorine, a reaction between chlorine and hydrogen, we get hydrogen chloride. Here we add hydrogen, so this reaction is reduction. Similarly, we have H2S and Cl2, hydrogen sulfide and chloride, and chlorine, we get HCl. So here hydrogen is added to chlorine, so this is also a reduction reaction. Similarly, we have ferric chloride. When we add it to iron, we get ferrous chloride, FeCl2. So here also we add basically iron, this electropositive element, to this chlorine. So this is also a reduction reaction. Similar, another definition is removal of oxygen. When we remove oxygen or any electronegative element. For example, we have HgO, what is this, mercury oxide. When we remove the reaction, when heat it, we get mercury and it breaks into mercury and oxygen. So oxygen is removed. So this is a reduction reaction. Similarly, we have ferric oxide. When we add it to carbon monoxide, we get iron and we get carbon dioxide. So here oxygen is removed from iron. So this is also a reduction reaction. Similarly, we have SiCl4 reaction with sodium. We get acid and sodium chloride. So here this chlorine is removed from this silicon tetrachloride. So in this case also this is a reduction reaction. We know that oxidation and reduction reactions are complementary. That is, they take place at the same time. When one substance oxidizes, at the same time another substance reduced. That substance which is oxidized helps other to get reduced, and that which is reduced helps other substance to get oxidized. So these two reactions take place simultaneously. So they are together or collectively called a redox reaction. So we call these two reactions which take place simultaneously, oxidation and reduction, as redox reactions. For example, if we take formation of water, the reaction between hydrogen and oxygen, twice H2 plus O2 gives twice H2O. In this case, hydrogen, oxygen is added to hydrogen, so hydrogen is oxidizer. So this is oxidation reaction. Again, hydrogen is added to oxygen, so this oxygen gets reduced. So this is a reduction reaction. Simultaneously, hydrogen is oxidized and oxygen is reduced. In this case, when hydrogen is oxidized, therefore oxygen is the oxidizing agent because it helps hydrogen to get oxidized. Similarly, oxygen is reduced. Here hydrogen is therefore reducing agent because it helps oxygen to get reduced. Let us take another example. We have ferric oxide plus aluminum. It gives aluminum oxide and iron. In this case, aluminum is oxidized because oxygen is added to it. Similarly, ferric oxide is reduced because oxygen is removed from this. And so this is reduction and this is oxidation. In this case, aluminum is oxidized, so ferric oxide is here the oxidizing agent. Similarly, ferric oxide is reduced, and therefore aluminum is the reducing agent because it helps iron oxide to get reduced. In absence of aluminum, this cannot be reduced, and in absence of ferric oxide, aluminum cannot be oxidized. So this simultaneous reaction of oxidation and reduction, one substance being oxidized at the same time another being reduced, is called redox reaction.